Hello everyone. In this tutorial, I'm going to showcase you how you can use the OSC protocol for getting the geolocation of your phone, and you can use that in Unreal Engine. I've already covered how you can use few sensors through OSC. So we use sensors OSC application on our phone, and we calculate the orientation sensor so that we can control the camera in Unreal Engine 5. Also, we use the rear light sensor of the Android phone to calculate the intensity, how much it is capturing, and accordingly, we are setting the intensity of the lights in Unreal Engine 5. So, today we are going to cover how you can use the geolocation of your phone in Unreal Engine 5. So, let's get started. So, I would just start with my OSC that I have created in the previous lecture. If you have any doubts regarding this, let me know. But you can rewatch the previous lecture in which I have explained you how you can actually create the OSC server and the receiver, etc. Alright, so this is the blueprint that we created for getting the orientation, and this was for getting the light sensor, and we are promoting it into the variable so that we can control, right? So here was the application we used, sensors to OSC, and connected to the save Wi-Fi, right? But turn on orientation, and also but turn on the rear light, which is this one. I would be able to control the lights and everything, right? Um, which was in this map actually that we controlled. So I can just play directly, and I am able to control the light as well as the camera through OSC, as you can see. Alright, now we will get started for getting the latitude and longitude value. That is actually the geolocation value through our phone, right? So let me get back to this level, the test level. Alright, I'll bring back my sensors over here. So currently I will not be using orientation, and I don't want to use light sensor. Let's focus on geo positioning. So let us first check what geo positioning gives. What are the values does it give? So address location, that means it will be slash location. Number of values it gives are 5, and this is the max range and resolution. That is the accuracy, I suppose. Okay, so we know that it gives 5 value. We need to know what are those 5 values. Let me turn this on. So you need to make sure that this application have the location permissions. All right, I will go ahead and give the location. I'll turn on the location, and I suppose I have already given the location permission, but I can just check it right from here. Make sure you give the permission over here, and also switch on use precise location. All right, now we are back here. We have turned this on, but we need to make changes in our OSC blueprint, because over here we are just getting orientation, and this is the address of the rear light sensor. Alright, let us create another case wherein we will get the address. So I suppose the address is slash location. So location, there you go. All right, now that we have this, let us create a delegate on location receive. I'll quickly call it. So when I get the location, when I get OSC message float at index, or let us first see what are the five values that we have, right? So we'll print five values that we have. We'll use the loop for that. Get OSC float. So all the floats. We'll get the message from here. Right, and let us get for each loop, and let us print, and we will get what are the values we are receiving from our phone. All right, uh, let's start this. I'll get the phone over here. So as you can see, these are the values that we just got over here. So this is the latitude, this is the longitude, I suppose. So 1, 2, 3, 4, 5. These five are the values that we are getting, as you can see. So 19.19, the latitude is the longitude. This has to be altitude. Uh, I guess this would be one of both of these would be pressure, but uh, I have to research about this. But these three values are latitude, longitude, and the altitude. One of these would be pressure. Research, I suppose that the values are latitude, longitude, altitude, speed, and pressure. These are the five values from the geolocation that we get. And this geolocation or the geopositioning sensor will only work when it is changing actually. So, so currently it is not printing anything, but if I turn it off and turn it on again, it will start printing. So this value will only we can get while we are moving, because when it will be updating uh, in the real world, it will throw the position, the latitude, longitude, and all those values. So let us promote it to variables. We just need latitude and longitude for now, but if you want, you can experiment with the other values as well. All right, so let us stop this and we will open up our blueprint, and we can get the two indexes, first two indexes. So I suppose first one is latitude, but we can change it after. So from this, we'll get OSC message float at index 0, and we will promote this value to a variable. We will call this as latitude, and let us duplicate this, and we will promote this one. Here is the next one to another variable, longitude. There you go. We have the latitude and longitude. Let's compile them. So here we have both of the values, and we can use them. Either we can use them in the level blueprint, or we can use them anywhere else we want. So find one location. So we will need to get that delegate over here. We'll get this. We'll find this on begin play. We'll create an event on location. We'll see event. So whenever we receive the location, we can get latitude and we will get longitude, and let us print them. Let's add them. Actually, we convert it into a string and we will append. So here we like latitude, and here we will write longitude. Alright, let us see how this works. So we have this in our level mixture. So turn off and turn on. So here we have the latitude and longitude. Just like this. So to make sure we add a space in front of it. So there you go, we have the latitude and longitude. So now what we will be doing is we will use Cesium, and through Cesium we will import the 3D map of the world, and we will place ourselves in a position according to our phone's geopositioning value. Right. So this will be pretty interesting. So for that, what we'll do, we'll go to plugins, and actually you need to open up Epic Games. We will go to Marketplace, and through here uh, we will search Cesium, and you need to install Cesium for your engine. So I'm using 5.4.1. Just search Cesium and you will see Cesium for Unreal. Just install it to your engine. I've already installed in my version. So after you have installed this, you need to enable this plugin, Cesium for Unreal. I'll enable this and I will restart. And we will configure Cesium so that we can use their 3D tiles. And after that, what we will do is instead of letting Cesium decide where is the latitude and longitude, we will give our values of latitude and longitude and we will feed them to Cesium so that we can spawn over there. So here I have the project loaded and we have the Cesium plugin enabled. Alright, so now what we need to do is configure Cesium. Alright, so we will actually go to Window, Cesium, just click on it and you need to connect to Cesium Ion. Then open this up and you can use your account to log in. I'll actually use a different account and I will log in into Cesium through Epic Games. And after this is done, you can directly use Cesium. I'll just click allow and now we can just close the window. So there you go, you get the quick add Cesium Ion assets over here. Let us create a duplicate level for this. So OSC, Cesium, OSC. And we'll open this level up and what we need to use over here is we can use the Cesium Sun Sky, but we actually already have the lights over here. But if you want, you can use these as well. So we will be actually using Google Photorealistic 3D tiles that I was talking about. So let us quickly add. I'll use the default token, or we can use a new token. And it will automatically add the environment over here. It will take a few seconds to load. You can see this depth over here is actually because of the height fog. If you just disable this, you'll see that everything is clear now. But if you enable this, you'll get this height fog. You can play with the values of the fog over here. We can change the density of the fog. If you want to reduce it, we can reduce the height fall off through here. Let's just we can just reduce this over here, like 0.01, and we can also reduce the opacity of this. You can just play with the values over here. You can add volumetric fog if you want to add some realistic depth in here. Yeah, you can just play with the values. Right now, I just disabled this, but yeah, it does add a really good depth in this. Okay, now that we have the photorealistic 3D tiles in here, if you go over to the geo reference, you will see that it is automatically getting the origin latitude and origin longitude and it's setting it somewhere in these mountains over here. So if you go on Google Maps and if you put on this latitude and this longitude, you will actually get in the same location right over here. Okay, so let's talk about these components. So origin placement is we are getting the placement through latitude, longitude, and height. If you go to true origin, it will get to the 000. Just reset this latitude and longitude, and according to the latitude and longitude, the georeference will place the photorealistic 3D tiles. It is creating this wireframe during runtime, right? And it is not much high poly. If I go a bit closer, I will get. But yeah, they have few vertices, but it does look good. All right. So as I said, we have latitude, longitude. The height is actually the altitude that you can set through here. As you can see, this is the current height through of this location actually. So in Unreal, as if you don't know, one Unreal unit is actually 1 centimeter in real world. Accordingly, this is the height of this, and this is just the scale actually. I just put these to default. Okay, so these are the components of the georeference of cesium, and these are the components of the photorealistic 3D tiles. So here we can automatically set it over here, but it will set it during runtime, so we don't need to actually set it always. We can set the culling, we can set the tile loading, we can set the level of detail through here. So many things you can play with. Maximum simultaneous tile loads. You can increase this if your PC can handle. So it will load many tiles at once. Right now. Alright. So we can also use the cesium, sun, and sky accordingly. Uh, Accordingly, it will actually set the day and night actually. If I play right now, I'll just spawn in here, somewhere over here. It is spawning, and as you can see, it is loading the area. You can use cesium, sun, sky if you need, but actually, it actually comes with high intensity of direction light. You can delete our direction light through here. You see, it has direction light, it has skylight, it has sky atmosphere. So I can remove those components from my scene actually. Sky atmosphere and skylight as well, and delete the height fog. It doesn't have. We have added it over here, but you can keep it or remove it accordingly. Okay, so the sun sky, you get the geo reference. You get the geo reference to the sun and sky. We can adjust the orientation for globe when moving. You can click on it. If you hover over it, you will get the definition what it will do. So it is just saying that we know that the earth is definitely not flat. So it gives an essence. So as you move across its surface, the direction of up changes. So you can enable it. This will automatically get updated. Radius, you can update sun accordingly. Date and time over here, atmosphere. Use level direction light or distant light of this one, it will automatically get actually. You don't need to set it through here. Okay. I'll not use level detection light because it is already inside here. I can use auto activate. When I play accordingly, it will set light intensity and everything. I'm not using the dynamic pawn of the Cesium because I'll be using my own pawn. Go to world settings. We have our game mode that we created, which uses BP player, like this. So when I press play, you see our blueprint spawns over here. Right, now coming to the main thing, how we can set the georeference of Cesium according to our sensors, right? Geopositioning sensor. So let's get started with that. So we will open up the level blueprint. As it was a duplicate of the previous level, it automatically have these things that we actually need. Instead of printing, what we will do is we want these two values to set the georeference. So let us get the georeference, and we need to set the latitude and longitude through here. So one thing to keep in mind, so this latitude and longitude is the real world geolocation, right? So how will Unreal know that my position, so this is the position in Unreal, right? So this thing, if I go to details panel, it is actually 000 location, this component, but it has a different latitude and a different longitude. So how will Unreal know that this latitude and this longitude I need to place at XYZ in Unreal? So Cesium was smart, and actually they made a blueprint component so that we can, a blueprint function, so that we can convert the latitude and longitude to the Unreal world, right? So through here, what I will be doing is, as I said, they have created their blueprint function to convert the real world latitude and longitude to Unreal latitude longitude, basically. So I will set origin, as you can see, set origin, longitude, latitude, height, right? So if you read, this aligns the specified longitude in degrees, latitude in degrees, and height above the ellipsoid in meters to Unreal origin, right? Now we will split this. So we get the latitude. So latitude x, longitude, latitude, height x, longitude, latitude, height y, and longitude, latitude, height z. So x, and we also want transform longitude, latitude, height position to Unreal. So we transform the given latitude in degrees x, y, z to into Unreal coordinates actually. Alright. So we will use this, but before that we want to use these two. Okay, so we have the latitude, we have the longitude right in here. So now it will set latitude, longitude, and height. We can get the height actually So height was the third. You can test that out. I'm gonna create a duplicate of this 0, 1, 2 and promote to a variable height. Let's compile it. Delete the message. Just like this. Alright. Compile, save it. We get height and just directly connect over here. But we should actually get the we can print this first. So that we know what is the height actually. So let us compile, save it. Press play. It is not updated yet, but if I try to change the geo position, and there you go, it has changed its position to somewhere. I'm currently in Mumbai, so it should change it to that. But let us check the height actually. Just giving some warnings. We have changed that to 50, right? So I guess we need to change it to 20 again. So it is giving us height as minus 22. So we can minus 22. Let us see where is the tiles. So yeah, there are the tiles. It is not fully loaded yet. Yes. I turn off the height for. What we will do is we will also set the location of our actor, our player actor. We'll add PP player in our scene. Just reset it right now. Set the game mode to none over here. Alright. Go to details. So auto possess player 0. Alright. So that we can automatically possess it when it is in the world. So let's get this and we'll set this location. We'll open up our level blueprint. Let us bring our player here. Set actor location. So we'll split. How will I bring my player to that position? Is same. We will get the latitude. So it is actually longitude first and latitude later. So longitude, latitude it is. So longitude Latitude, so here as well, and the height over here. I'm not sure whether the height will directly uh, reflect there perfectly. Let's just check it for now. Press play. Let us bring this and we will update our location now. I suppose we are reaching there. So yeah, this is actually my current location. I just quickly hop out. So we are currently here in Thane. It will not load when you are outside. It will only load if you are here. And if I turn on my orientation, I can quickly move around here. As you can see, I turn off the orientation. Let's pause it and get the geo reference over here. Getting 19.90 and you're getting 72.19, I suppose. Which in height it was getting 22. I suppose it was minus 22. I wanted to search, yeah, this one. We are not printing the latitude and longitude right now. I was trying whether let's manually put the latitude and longitude and see. Longitude, latitude and height we have here. We print the appended string. So 72.96 and 19.19. Let us directly put it here and we'll check. Still some error over here. Okay, 72. This 19 and this. Okay, I've copied all these values. So 19.19, 72.96, and minus 22 it was. Right. Let us actually get the cesium over here. I'm trying to get the exact location actually. And we can add road with labels. You can also click on buildings. It will add buildings. But unfortunately in India, uh, we do not have much larger data set, right? Added few buildings, but I am sure it is not correct here. You can see some of them are inside. You can set the height of these buildings through here. Somewhat like this. You can get with labels so that we actually know. Let's add this. We'll get the map below us, but this map will be with label. I'll turn this off and turn off the buildings as well. So I was actually in the exact location where I live actually. And we are also getting the perfect height because I'm sitting in a building right now. That's why. So that is amazing. Let us delete the, we don't need this. You can get the buildings over here. So yeah, this is how you can actually get the geo-positioning data. I will turn off and turn this on again. Well, it is set automatically. Where I am. It's the sun and sky. It is not getting updated right over here. If I put my geolocation, accordingly it will change where the sun and sky is. Something like this. I'm not sure about the rotation over here. It is automatically setting to something. You can set the time zone over here, which year 2020. Or accordingly it will set actually. So you can play with these values. This is just the environment actually. Suppose I have put the proper latitude and longitude. Yep. Well, it sure is cloudy, but it is not. The weather doesn't look like this. Correctly. All right. So this is how you can get the geopositioning data and use Cesium in Unreal Engines. You will get the geopositioning data from your phone, and through OSC you are setting your location inside the real world map through Cesium. So thank you so much for watching my tutorial. Stay tuned for more.